cartons.
That lends a lot of credibility. If you come in and can be upfront and honest and say, actually in this application, I think this product over here that I don't represent would be better for you. That all of a sudden now you become a trusted advisor rather than a salesman.
And I often say that we have all the requirements of space, right? Because it has to go underground and send us data from miles and miles away, and it has to work. Like, failure is not an option.
We'll put on, a standard mule shoe. Ours is slightly different just for that, but it's, everybody's got one.
The top drive and the drawworks really don't care whether the electrons coming at it are from a joystick or a PLC.
The panel, what you see here on the left, which is now controlled by one of my students, is showing you actually the control of our brakes.
As of now, geothermal is a pretty small market.
If you have tortuosity, the casing will be up against the side on part of the well. There won't be any cement there. The cement will have crescent around it.
So managed pressure drilling, it's been defined as a process to precisely control the pressure profile in the wellbore.
The key is being transparent with our clients in this case. So tell them what happened. If we had a failure, tell them exactly what happened. Whether it's our fault, whether it's whatever the issue was, we need to be transparent.
But I think it's very important for everyone in the industry to know what's out there and kind of what's happening downhole as well.
I've probably worked on over 40 different performance limiters in my career. If I miss any of those and the computer is raising weight on bit and I miss any of those, I have a train wreck. The computer's going in the ocean.
Here's your new colors, here's your new thing. We won't do that
at all. Here's the tattoo you need to get.
Yeah, here's the tattoo. Sorry about the last one. We used to fake that all the time.
Hello, everybody, and welcome to the Vidor Locksmith Show. I'm your host, David Gibson, where we are unlocking the secrets to success in the oil and gas industry, one interview, one presentation, and 1 week at a time. I am so happy for everybody to be here. Happy New Year. It's an amazing year already thus far. I've got a lot going on in my world, and I'm very excited about. I'm really excited that the kids have gone back to school and are no longer, I shouldn't say bothering me, but where we're having to do board meetings and donuts and where's Waldo and guess who in the midst of trying to do work as well. So it helps me to be able to have a full day to do work, even though Fridays I really don't do any work and just hang out with you guys. So for everybody that's out there, let us know if this is your first show that you're watching. Would really appreciate it. Also, need some feedback from you guys about the new way that I set up the show on LinkedIn. I know that I put the event as 2022. I did that on purpose. So what I'm going to try to do is do a singular event for like all of 2021 and just put them as their 2022. So I don't have to send out an invite every week. I just send one each week for new people. And then if you just like the show, you just click on that event. And then every week I'll just keep adding to that event and putting more stuff in there so that way you see whoever the guest is for the upcoming week, or you see the show, or if you want to be a part of the conversation. It's just something that continues to happen over time, as opposed to making an event every single week and everybody logging in every single week. So just going to try to do that. I think that would work out a little bit better. So we're going to test it out for the month of January. This is I'm trying to make this like the MWD month. So we'll give it a shot. If it doesn't work, it doesn't work. Hey, at least we tried something. We're always going to be pushing the envelope here at Gibson Reports, which is actually the title sponsor of the show. I don't make any money off of the show. I make money from my business. There's the logo, Gibson Reports. So, guys, give me some feedback about that. Also, let me know where you guys are watching from. We've already got plenty of people watching already. So, guys, don't be afraid to type over there on the keyboard and let us know where you guys are watching from. And like I said, let us know if this is the first show that you've ever seen. Always happy to be able to hear about new guests that are coming in. And also, here's a question. If you have ever run an MWD tool before. So if you've been an MWD hand, or if you've been a company man or a directional driller, if you guys have been out on location running EM before, let us know. Happy to be able to hear about some of the other experts that we have in the audience. So Ryan is tuning in. Thank you, sir, for being here. I do appreciate it. Been on Ryan's show. It's the example show. He interviews other podcasters and live streamers to be able to show an example of how to be able to do it. It's a great show. So definitely tune in. He's doing it LinkedIn Live, as well as a couple of other platforms as well, but mainly see him there on LinkedIn. So hola amigo, Nicholas Williams. Nick, thank you so much for being here. Checking in from Thornton, Colorado. I didn't even head up that time at some point, or at some point in time, be able to head up there. So Andrew says all good. There was on 2 of them there, but it can be kind of tricky when you hit the enter button over there. Hakeem says, hi, David. Well, hi, Hakeem. How are you doing? Johnny Corca says, howdy. I always say this. You guys got to check out some of the stuff that Johnny's putting on LinkedIn. A lot of really, really cool Python stuff. So if you're into programming or doing stuff in Python, be sure to go and check him out, get hooked up with him here on LinkedIn. Patty Murphy, as always, thank you, sir, for being here for today. One of our probably most loyal fans here at Lee House. Lee, thanks for being here, sir. Appreciate that. I don't know if you guys can tell. I actually put there. I always get confused doing this. There's the lights. We put them on a little twinkle today or fade. So it's kind of almost a Christmas-esque. All right. Oh, wow. Hit the wrong button. Oh, and everything moved. So we got Marco tuning in from Erie, Colorado. Graham Mintz, who's a previous guest on the show, which I'm very appreciative. We're going to definitely, Graham's going to be on the show again this year at some point in time. Not sure when, but we will get it scheduled. We'll get him to come on. He's got so much to talk about and so much passion to be able to give back to the industry. Watching from NL, the Netherlands. He put this on there before and I got it wrong. So this time we're getting it right. So Netherlands. So I also said last time that it was Newfoundland. So there's 2 different NLs there. They're all from Trinidad and Tobago. Kevin Levine here from Oklahoma's Winter Mud LLC and Outdoor Adventures. Feel free to plug your company on my show for free. John Barks, MWD coordinator at Cathedral Energy. So we do have Joel Dunn on the show today, who's going to be talking about EM telemetry from Cathedral. So very happy that they are here. Carla from Amsterdam, thanks for being here. Lee says he's on a job right now running EM. That's what I'm talking about. Laura Plaza from Colombia. Wow. All right. Ryan says, I don't even know what MWD is. Measurement while drilling. I'm actually going to be this little taste of the future here, guys. I'm going to be doing a MWD series here very soon. And it's not going to be staged here. It's going to be staged right there. Been rebuilding the set. We didn't finish it over the holiday break. We got a lot of other things done that are not on camera, like everything behind the camera and a new camera sitting over there. Everything, some stuff came in late. Some things are getting delivered tomorrow. The Christmas holidays and people buying stuff really kind of foiled my plans because I thought the thing that I was buying wasn't really a holiday gift, and it turns out it was. And so all the shops were sold out of them. So I had to wait till they come in. So we're trying to get that done. But yes, we'll be doing a What is MWD series hosted by me, or I will actually be teaching you guys something other than just always having the guests come on. So it'll be something completely different. I'll be sitting over here, and we've also got the other side of the office set up to be able to start doing some in-person interviews again. So Marco's saying EM Mercury Sperry. All right. Wow. I clicked too far on this again. First show from Alberta working as MWD. Well, thanks, M. Gallen, for being here. Kevin gave us some rock on stuff here. All right, cool. Patty Murphy says, sure, EMGMS way back in the day when our oil was still walking around and eating vegetation. We got Ari here from Dubai. Need to brush up on EM. And Johnny says, thanks for the plug. Hey, anytime. Thank you for the stuff that you're putting out there. Scott Hoover says he ran parallel telemetry. Khalid, hi from Iraq. Brian Dugas this morning from Bowbridge. Brian, thank you for being here. He is a MWD expert. So if you guys are looking for somebody who's really sharp in the MWD world, Brian is the guy. So we got Vahi from Iran, Muhammad from UAE. Artie Morrison says movie watching duty. Might work downhole, might not work downhole. Movie watching dude. Give us some other great MWD acronyms what they actually spell out here in the comment section. George Sodden says, hi from Saudi. Thanks for being here. David, I am your biggest fan. You're so much sexier with the beard. Oh, thanks, Ken. I'm glad you're my biggest fan. It says, first show from Alberta. Kamal says, hello from India. From India, I think I'm all caught up. Cool. Tuning in from New York. We manufacture composite MWD shields and housings. Well, who are you, Shane? Product sales engineer at Trelleborg SELI. I'm guessing that's C something. I don't know. Whatever. Money while dozing. That's the first time I've heard that one. That's a good one. Movies while drilling. Monkeys watching detection. And then Ray Step says hi. Well, hey, Ray, thanks for tuning in. I think Ray's actually a drilling engineer. Look at that. We got drilling engineers. MWD. Okay. All right, guys. Thanks for being here. I really do appreciate it. We've got lots lined up for this new year. Like I said, redoing the studio in here to be able to give this a different look, have the MWD series as well as other technical series that we're going to have lined up over here. We've got the backdrop set up for being able to do in-person interviews again, as well as potentially a entrepreneurial podcast that I'm wanting to do. Trying to think of everything else because I don't write notes before this because we're just going to do it live. Trying to think, there was something else I wanted to be able to tell you. Anyways, next week we've got Manoj Gopalan and BJ Weber from Rhyme coming on the show together. I do not be surprised if Manoj dresses up as a pirate for next week's show. I would be disappointed if he doesn't. I've been trying to get him on the show forever, and every time I ask him, he's like, "Can I dress up as a pirate?" And I've always told him yes. So he's planning on being on the show next week. The week after that, we're actually going to start a little bit later because K&M Energies or K&M Services, K&M Technologies, whatever their company name is, they're going to be having a show from 9 to 10:30. So with Fred Dupriest, I know that one will probably go long, and a lot of my audience would probably be an audience that would be tuning into that. So I don't want to have to cut theirs short or make them start earlier. So we've been kind of working together on this. I'm going to start a little bit later. So my show will start at 11 a.m. on the 22nd with Paul Madera, who is the VP of drilling for Baker Hughes. And we're going to be talking about the future of directional drilling, the drilling automation and remote drilling services, and everything else that's special and new with Baker Hughes. So they will be on the show. Drilling engineering specialist from Algeria, whoever that is, need to dress up as a pirate also then. Thanks, JP. Sure. I'll just dress up as a pirate too then. Okay, Ozzy Silva tuning in. Thanks for being here, sir. Paco from Spain. I think he's the first person we've had watching from Spain be able to bring that up on the show. Fahim got a job. Yes, Fahim got a job. So we used to do a minute with Fahim, but Fahim got a job. So he's no longer allowed to be on the show. He's no longer allowed to do any work with me because he's under strict rules and stuff. A place, something that I would not do very well with. I would want to break all of them, which we like to do on a normal basis. Anyways, so we'll get ready to kick off the show here. We've taken long enough. Somebody complained about it once upon a time, but I didn't care. So, guys, we've got an amazing guest here today. Joel Dunn is going to be teaching us how EM technology works, electromagnetic telemetry, how it works. Last quick thing, as I'm trying to remember where the button is. There it is. Haven't done this in a while. We've got 4 companies that have signed up to be able to do season 2 of How It's Done. If you want to be a part of it, get in touch with me. We're looking for more companies to be a part of the series. It's an absolutely amazing series. My mom is the videographer. She goes out there, films, and does everything. This has been talked about. It's one of the best shows in the industry, and we have a lot of oil and gas operators, big companies that are watching this show as a way to be able to educate themselves and their entire departments. So check this out, and we'll be right back with our guests. And I welcome to the show Joel Dunn. Joel, thanks for being here, sir.
Thanks for having me, David. Excited to be here, man. First show of the year.
Yeah, that's right. This is the first show of the year. I thought I was going to do some live experimenting and stuff, but didn't do it. So you get to be the one to kick off 2021. So if this year goes well, then all the credit goes to you. And if it's terrible, and all the blame goes to you.
Same.
So, or to your boss. We can just throw it off to somebody
Fair
else.
enough. Yeah. There we go.
I do have to put this out there. Eric is watching. Eric is probably one of the most dedicated people to the show, always sharing the posts on LinkedIn. So, Eric, thanks for being here. All right, Joel. So tell us a little bit about your background and how you got to be so involved in knowing so much about EM telemetry.
Okay. Well, yes, I've been around for a while. I started in the oil field in 2006 with Schlumberger. And actually, interestingly enough, my first MWD job, I broke out on EM telemetry, or EM MWD. So that was back when the Fayetteville Shale up in Arkansas was running hot, and yep, we definitely used that tool. It was the ePulse XR, I believe, at the time. So yeah, that's kind of how I first got exposed to it, and then yeah, over the years, I mean, it's a very interesting technology. It definitely has its applications where it's superior in certain ways, and we'll kind of talk about some of that later. But yeah, that's kind of what my background. I started at MWD. I went into the Operations Support Center for Schlumberger for a couple of years. Went to the directional side, directional drill for 5 years, and kind of when I came into the office, did some management stuff, and yeah, left Schlumberger. I'm here at Cathedral now. So
yeah, don't forget to plug your company that you're with. Otherwise, all your coworkers.
Oh yeah, no. Yeah, just
watching. They're gonna be like, hey.
No.
All right. Well, then I will go ahead and let it kick off to you. I will go ahead and bring up your presentation and let you be able to start educating us, guys. If you are watching, if you have any questions, we want this one to be extremely interactive because that's kind of the best way. Were you in Conway then, Joel? I was there in 2010.
Yes,
that was a question there. Oh, maybe you guys work together. Cool. So, guys, I want this to be really super interactive, and I have to give a quick update. Make sure you're actually watching this live. So, like, refresh your browser, or that, like, it actually says you've got the little live thing at the top, because then some people had told me they were asking questions, but they were coming in minutes late, or they were coming in hours late. This is a live show, so if you're kind of not up to date on where we're at, then we probably won't get to your question. So, all right, Joel, I'll push this. Wait, what does this say? Remove. Oh, I just need to do that. No, not me. No, there we go. All right, Joel, your turn. Take it over, sir.
All right. Again, David, thanks for having me on. Yeah, today we'll be just kind of talking about some MWD stuff. Let's see. It's not updating there. Let me make sure I've got. All right, there we go. So the way I think I'm going to break it down today to kind of go through the basics of how MWD works is first I'll give a little introduction, kind of an overview to MWD systems as a whole, because I mean, based on some of the questions we've already gotten, you know, the audience is extremely diverse. So there may be some out there who aren't really familiar with MWD systems, and this kind of be a good way to get started. Next, I'll move on and talk a little bit about electromagnetic EM in its general sense. When you kind of hear EM and you think about it, what normally comes to mind initially, versus electric dipole or a current loop system, which is kind of a very important distinction. We'll make, then talk a little bit about the origins of the technologies, how they were adapted to the oil field. Then we'll get into the theory, principles of operation, kind of the nuts and bolts of how everything works. And then I'll talk a little bit about some considerations and limitations to the technology. Yeah, and then I'll pretty much wrap it up. So let's move on. All right, so measurement while drilling system. Basically, an easy way to describe it is we have tools downhole. They take various measurements and they send them uphold. There's various mechanisms to get them uphold. We'll kind of go over the systems here, the components. I found the easiest way to break it down is kind of into really 4 parts. The first of which we'll talk about is a measurement component. Usually this consists of, it gives you your directional measurements, your inclination, azimuth, to give you your position in the well bore. It's also responsible for taking measurements of the drilling dynamics, usually temperature, any tool status words, anything that's going on with the tool. And this information is typically used to steer the well bore and to monitor the downhole conditions. Next is a logging component. It's not required to have a logging component in an MWD system, although commonly there is, at least gamma ray. And basically the logging component takes geological measurements. It measures the formations you're drilling through in more or less real time. And it's used, this information is used to determine the characteristics of the formation you're drilling and to kind of give you a wellbore position in reference to geology and geological markers. Next component is the telemetry module. This is actually what gets all the data from downhole up to surface, where we can actually use it and interpret it. There's several methods that we can use to get the data uphole, which is what we'll talk about here in a little bit. So basically what happens is the measurement component kind of compiles the data, packages it, puts it in a form that will be recognizable by the surface system, sends it up to the telemetry module, which will then modulate the data and then send it to surface by whatever means the telemetry module set up for, whether that be mud pulse or EM or a wire drill pipe or whatever that might be. Finally, you have a surface system. You always have to have something on surface to, like I said, receive the data, demodulate it, integrate it, and just kind of, basically interpret it on surface. This usually consists of pressure transducers, acquisition modules for acquiring the signal, computers. It's usually tied into the depth tracking system, especially for directional positioning. So those are typically the 4 components. I mean, there are other things involved, like obviously you have to have a power source downhole that could probably be thrown under the measurement component. Usually it's batteries or sometimes the downhole generator to kind of power everything. So yeah, the first 3 modules there, those are downhole, and then again, the surface system is all the equipment that's on surface. Since we're going to be focusing on EM telemetry specifically for today, so we'll kind of look at that just a little bit closer. All right, so there's two primary types of telemetry that we use in MWD systems. The first I'll talk about quickly is mud pulse telemetry. Basically, mud pulse telemetry uses the pressure inside the drill string as a medium to transmit a pressure signal, or essentially an acoustic pressure signal up the hole, which is measured by pressure transducers on the standpipe. So when you're pumping at a given flow rate through the drill string, due to the ID of the pipe and the various restrictions downhole, it generates pressure, and that pressure is typically pretty stable at a given flow rate, stable enough where introducing pressure fluctuations can generate a signal that can be detected on top of this residual pressure while pumping. So yeah, as you know, you pump the fluid, drilling fluid, through the inside of the drill string, exits the bit, and then typically what happens on the MWD tool is there is some sort of orifice or some device downhole that restricts flow. And when you restrict that flow, you create a pressure pulse. It can be done by like a plunger type orifice, or maybe like a rotary valve or something to create more of a sinusoidal wave. But yeah, those pressure fluctuations are picked up by the standpipe on surface, decoded by a computer, and then that's how the information gets from downhole to uphole to the surface for mud pulse. EM telemetry, on the other hand, uses the electromagnetics to get the data from downhole up to surface. So basically the way that works is there's an electric dipole separated by an insulator downhole, and you measure a voltage difference between two antennas on surface. They don't necessarily have to be the BOP and a separate grounding rod. It can be two separate antennas, or you know, in any arrangement. There's several ways to do it. So yeah. So what happens is in most tools, there's the polarity of the dipole is cycled back and forth, reversed, and then switched back. What that does is induces a current loop in the formation, which is measured at 2 points. You take the voltage difference between those two, and because the polarity is switched at a periodic rate, you can create a waveform from those fluctuations, and yeah, and you can demodulate it to signal that way. So I think yeah, just to kind of define a couple things here. EM in the typical sense, the EM and electric dipole are sometimes used interchangeably. However, they are different manifestations of electromagnetism. Usually when you think of EM, one would, you know, typically think of like radio waves, like your cell phone or the radio station broadcasting that you pick up in your car, or something like that. And now, while radio waves or electromagnetic waves in that spectrum can penetrate rock very effectively, the only way that only occurs at low frequency. At high frequencies, they're attenuated and they do not penetrate very far through rock, even homogeneous rock. And when we're drilling, we're definitely not seeing homogeneous formations. And in order to produce these low frequencies, that would be required to get from, you know, say 10, 12, 13,000 feet TVD up to surface, the antenna is required, or the transmitter is required to have to be extremely long, because the wavelengths for these low frequency waves are extremely long. And usually this design is really not feasible for drilling, mainly just because of the length. And if you were to be able to put one downhole, you've got to contend with dog legs, pressure, shock vibration. There's a whole bunch of things down there. It's just it wouldn't be a good fit, at least with current technology. On the other hand, we've got the electric dipole. But basically the way this works is it generates an electrical current as opposed to an actual like radio type EM wave. The current is produced from a dipole that's situated downhole on the MWD tool. It requires an insulator in the drill string to separate the two poles. And it also needs a medium for the current to be transmitted through. And in our case, it's the mud, the formation, and the drill string, and anything else that lies between the two. Most E&M tools utilize the dipole or current loop technology, and it's been that way for quite some time. So I just kind of wanted to, you know, introduce those two terms and kind of, you know, reference basically the mechanism for which we're going to be focusing on today. And then here's kind of a schematic representation between the difference of the two: electromagnetic wave, the oscillating electric and magnetic field. You can produce it. It can be transmitted and or received through a magnetic induction coil or like a dipole antenna or something like that. In contrast to the dipole or the current loop, which there's a little schematic here of our particular situation with a dipole downhole, and it shows you the current paths there in yellow. So just kind of a quick little visual there. So yeah, let's talk about where this all kind of came from, how EM became a thing. Well, it really got its origins back in the early 1980s. The Department of Energy was investigating, did an experimental run with dry air in Nevada, drilling a few wells. A company called Geoscience was the earliest developer of this technology, and it was funded from a grant from the Department of Energy. Just to kind of put the little context on this, back then when they were first trying this out, they were shooting for a target mean time between failure of 50 hours, which by today's standards is not really impressive. But what it did do is kind of establish that this was a viable technology that could be utilized more widely in oil and gas operations. So kind of going a little deeper into, you know, how it came about and how it became one of the primary methods of telemetry. First started with GeoService in the early 80s. They kind of took over from there and helped develop the technology a little bit, not to be confused with Geoscience, who I just referred to, two different companies. And then later in the 1980s, Sperry Sun really kind of moved the technology forward. Mainly they did so by adapting or finding an application for it with two-phase or underbalance drilling. That was kind of what really pushed them to really put some resources into the development of the technology. They also found that it could be very useful replacing single shot surveys in shallow gas wells. And also they definitely capitalized, they saw a good opportunity to capitalize on the survey efficiency or the time efficiency, mainly of surveying. Then later in the 1990s, Scientific developed their EMWD tools. 2003, Cathedral designed and produced their first. And yeah, since then there have been many companies, too many to list, that have developed their own technology or you know, that are in the EM game. So a couple of the initial applications, I kind of touched on it just a second ago. First of all, underbalance drilling while using two-phase or mist or air. That was definitely the biggest driver for developing the technology further, because mud pulse simply does not work in these environments when you're dealing with compressible fluids. Also shallow wells. This is one that we still kind of find as a really good application today when the shallow wells are very high ROPs. Mud pulse can sometimes be a little bit slow in sending the surveys, whereas, you know, you've got it pumps down, make your connection, pumps up, wait for the pressure to stabilize. And sometimes you can go back to drilling right away if there's not a whole lot of noise in the system. If there is, you have to wait for the survey, and that can be a couple minutes. With EM, the survey can be taken while the pumps are off, while the connection's being made, after the BHA's had a chance to settle down and not stop moving. So it's a good survey. So yeah, it basically eliminates the wait time there. So it also has applications in the deeper wells that are somewhat complex, especially where you have issues with mud pulse detection. A few things that could cause that are, you know, if you're running, even, it says multiple agitators, but even one agitator, if it's not set up correctly to work with the MWD, can cause some serious issues in mud pulse detection. Also, some oil-based muds and aerated muds, you know, they're going to attenuate the pressure signal as well. So EM is a good option there, especially with the oil-based, because it has a higher resistivity, and that kind of helps our cause here with EM. So survey management is another one. I kind of touched on that, not in addition to kind of having to wait for the pressure to stabilize and the survey to come up. Sometimes that can take a while with the lower data rates when you need to send all of the raw data, like all of your accelerometer and magnetometer measurements for the surveys. Also, you know, in some of the deeper wells, you have some issues surveying on connection. That algorithm kind of gets a little distorted as you get deep, measure depth wise. And this is actually really good opportunity for dual telemetry, to utilize dual telemetry. So now we'll kind of get into actually how this technology works. Really, the key is the gap sub, which I'll kind of go into a little detail here. It's really what makes the technology possible. It's basically, you've got a downhole sub. It's split into two conductive parts separated by an insulator. It forms an electrical break or an open circuit, if you will. And because this is a downhole component that goes into BHA, this insulator that's separating the two has to be able to withstand the weight on bit that's experienced downhole, the torque, the bending, overpull, and all the other forces and shock and everything else that happens downhole. So it's really a key, and it needs to be done right so that you reduce the risk of, you know, breaking at that point. So inside the gap sub it will be your transmitter, which will ride internally, and it also is kind of constructed the same way. You'll apply a voltage to either side, separated by an insulator, When you want to send signal to surface, you apply voltage across the gap. That'll induce a current, and depending on the specific type of tool, there's two ways to get the current. You can either do it in a burst where you energize the system and then you turn it off and energize it again periodically. That'll kind of produce pressure pulses. Or not, it'll be similar to like a linear pulse tool for mud pulse. That's kind of the analogy there. Or you can reverse the polarity, which will give you more of a waveform, where you can switch back and forth between the two. So you'll measure positive, negative, and then you can vary the frequency at which you alternate the poles, and it'll give you a phase shift, which can be demodulated at surface. So one thing that's important when kind of considering the operation is the formation contact. So the gap sub and the tubulars are in contact with the formation all along the drill string at different points, depending on your wellbore profile. Each contact point, a portion of the power supplied to the transmitter is injected into the formation. Again, it creates a current loop to the surface through the earth, through the formation. Second path will usually travel up the drill string because that's kind of the path of least resistance. And the signal can be measured in the difference between the voltage between the two. In terms of principle of operation, how it actually works, it could really be simplistically and conceptually visualized as just a basic circuit diagram. Really, the two main physical principles that come into play here are Joule's law, which relates the power to the current and the resistance. The drilling fluid and the formation across the gap are the resistance across the gap in the gap sub. And for a given power from the transmitter, a current is output or is output into the formation, as I just mentioned, and yeah, so they're related by Joule's law there. Ohm's law also comes into play because that relates the voltage to the current and the resistance. And again, the voltage is a function of the power and output of the tool that the transmitter's trying to send. So let's kind of look at a couple different scenarios and how the tool responds in a couple different profiles. For very low resistances, as the resistance approaches zero, if you've got some very conductive formation and in conjunction with water-based mud with high salinity, you can get very low resistances. What this does is it basically produces a short circuit, and as the resistance approaches zero, of course it will never become zero, but your current grows very large very quickly, and this can destroy the transmitter board chips because they're usually not equipped to handle that type of current. Some systems will include an inline resistor. However, this does tend to produce waste power and generate heat. But it does help because if you've got really conductive formations, you need some type of resistance, and that will provide a residual resistance. Other designs can depending on knowing where you're drilling and knowing what your resistance profile looks like, you can design your systems to handle more than the normal amount of current. And this actually results in a wider operating envelope. So that's one solution to deal with low resistances. Now we'll look on the other end of the spectrum, high resistance. As the resistance increases, the transmitter current decreases drastically because same law here, Ohm's law. As if the voltage, even if you increase the voltage, if the resistance gets extremely high, there's not enough, it's insufficient to get the current to complete surface. And also this kind of comes into effect during rotation where you reduce the wellbore contact. There's obviously less contact with the wellbore itself, especially in oil-based mud situations, will tend to increase your resistance. Some solutions to this problem, limited battery life. It's kind of one of the downsides to using more power, which is really the only way you're going to overcome the high resistances. There's also some options for generators downhole to kind of assist the batteries there to kind of help you run lower or higher power settings rather, and lower the drain on your batteries. And we also must, the boards must be designed to handle the extra heat from the increased power required to transmit the resistive formations. And again, so the power will typically increase without any adjustment when rotating versus sliding. So again, let's kind of look a little closer at how the signal is generated. The signal gets to surface by two paths. Again, one through the formation, and one typically through the drill string. On surface, you have a ground rod or another device, an old wellhead or just something that's not connected to the drill string to serve as one half of the dipole, and the BOP in most cases usually serves as the second half. But it can also be two independent antennas. There's several ways to have it set up. And then yeah, a computer on surface as part of the surface system measures the voltage between the two antennas and decodes it and makes useful information out of the data. A couple things to consider here when you're considering running EM is that the deeper you go, obviously, the more signal is attenuated because there's a greater distance. Detection improves as you lower the frequency. So the frequency of the polarity switches can be adjusted. It can be programmed at the tool prior to the run. Higher frequencies, obviously, you can transmit data faster. Lower frequencies, the detection improves, but you kind of suffer with the speed of transmission. And kind of it puts the brakes on how fast you can transfer the data. Kind of a quick analogy there is just, if you're going uphill in a truck, to switch to a lower gear, you get more torque. So most EM tools functionally operate usually between 2 and 9 hertz. I mean, 2 is probably the really low end, and some of them go quite a bit higher than 9, especially in shallow applications where there's not a whole lot of noise and you're not traveling very far. I've seen technologies that can go up to 12, 15 hertz. So usually anything faster than 9, though, doesn't work in the deeper formations. And some of the more sophisticated EM systems do have downlink capability where you can change the power and frequency on the fly, so you can run a higher frequency uphole to get your data a little faster, and then as detection becomes potentially an issue, you can either increase your power or decrease your frequency, or both, or any combination thereof. So it's kind of just a little closer look about how the signal strength decreases or diminishes with depth. There is a functional limit of the power output. So, as you get deeper and your signal strength starts to diminish, you can always add more power, but there are some limitations there. One being the battery life itself, and obviously that comes with a cost. As batteries deplete, the cost goes up. So, and simply increasing power again is not always a standalone option. And in addition to depth, there are a lot of other factors that have impact. Most namely the formation resistances, which can tend to change as you drill. So looking a little bit more at detection, again, lower frequencies transmit to surface more effectively. Trade-off there, again, is speed versus detection. Shallow wells, 5 to 15, should have no problems. 2 to 3, when you get really deep, that's kind of about the range you're going to be in when you start looking at 10, 11,000 feet TVD. So static mode survey usually has better detection than rotation. As we kind of touched on just a little earlier. Some tools have downlink capability, again, to change the frequency and all these other things as you drill. All right, so yeah, looking a little bit more at detection. The signal downhole can be 10, 20, I think, there's a pretty wide range for the voltage that can be applied for the given power, and that'll depend again on the resistance. But on surface, sometimes it could be as low as 0.1 millivolt. So you can imagine with any noise in the system, that's going to really kind of affect your demodulation and how well you can decode the data. And one way to combat that is obviously to increase the power, but also if you have really good algorithms and filters, electrical filters, you can filter out a lot of that noise on surface. But yeah, I mean, so you have to, have guys that know how to do that and know how to construct those types of electrical filters. And yeah, usually we measure signal detection. It's quantified, and the quality is quantified in volts. We measure the potential, amps, the current, obviously, and then most importantly, the signal to noise ratio. Because even if you have sufficient voltage, a voltage difference, if your noise is even stronger than that, you're going to have trouble demodulating. So yeah, there's several types of noise out there that'll affect power line transmission noise or power transmission, which we typically operate here in the U.S. At 60 hertz. That can become a problem. A lot of pipelines, if you're drilling a well and you've got pipelines nearby, cathodic protection usually is in the 1 to 2 hertz range. So you can imagine if you are in a deep well, you're using 2 to 3 hertz or any harmonic of that, and the cathodic protection can really cause some issues there. Sometimes the rotary can generate noise as well. That'll interfere. Other EM systems being run in the area, ungrounded rig equipment. Those are all some types of noise. There's many others. Anything that can produce electric interference will tend to contribute to the noise. One way we can look at that is plot the noise in a frequency domain, like using the fast Fourier transform, and it'll kind of help you decide or kind of help you figure out where the noise is coming from. So yeah, that's kind of some of the ways we look at detection. And yeah, I think that pretty much sums up what I have for the presentation part of it. I hope that was informative. I guess we'll kind of have a discussion here on out to kind of talk about some of the things in more detail. So
excellent. I was very, very informative. Thank you so much for that, Joel. Let me click the button here. People will take that one off the screen. So we did get a handful of questions, and a couple of people did answer some of the things in the comment section, but I still want to be able to give the opportunity to put it up here on the screen for everybody and whatnot. So here it is from Eric. What is the influence of drilling fluids weight and rheology when pulses are used?
So
that kind of goes to more of a mud pulse question, but let's also just use it for the EM side of the question as well.
What was that? The audio kind of cut out there.
Oh, okay. I would say just answer the question in regards to the EM side of it. So drilling fluids, weight, and rheology when EM is used.
Okay, so typically, yeah, the weight and the rheology in terms of the viscosity and things really don't affect it much. It's most dependent on the resistivity profile of the mud, the resistance that it provides for EM.
All right, we've got another one here. When using gasified fluids, what will be the maximum recommended gas fraction where mud pulse telemetry could work, and beyond that EM or wire drill pipe should be used?
I don't. I'm not sure what the gas fraction there, or what the ratio needs to be for mud pulse to stop working in EM to become. I do know with air itself or low two-phase with the low liquid fraction, mud pulse won't work. But I don't know that exact number for what gas fraction kind of, I guess, makes mud pulse obsolete.
Here's a great one. So Salim is actually the drilling manager there at Sonatrach in Algeria. Is it needed to have coated casings to avoid signal attenuation?
No, it's not required. I mean, most wells don't have them, and we can adjust for that. Our tools work just fine without coated casings. Most tools out there, don't require it.
Excellent. Brian Dugas says, are there any air-generated EM tools? Or air generator, not generated, air generator EM tools?
I'm not clear on that.
So like a downhole turbine generator that runs off of air instead of just mud?
That I don't know. So I mean, we have a downhole generator in our arsenal that as long as it's got fluid flowing by it, it would probably have to be adjusted for for air, but I don't see why it wouldn't work as long as there's flow. So
I'm just seeing if you guys use it there. Whole metal string act as an antenna. Not really sure what exactly that entails, but feel free to take a stab at that if you want to, Joel.
Okay, not really sure with it, but maybe he's referring to like if in an offset well. So you've got one end of your receiver hooked to the BOP. You've got another offset well, say quarter mile away or something like that, and you've got enough wire, you could connect to that and use that, and that would actually be a fantastic antenna if you could do that. So
is it better for the signal to travel laterally than it is vertically? Is that correct?
I'm not quite clear on that. So it'll travel in a loop, right?
Okay.
What was that?
Oh, it's all right. It's all right. We'll go to the next one.
Okay.
While air drilling or dusting, have you come across any solid techniques for improving signal?
That's actually a good question. I don't know. I'd have to probably refer to get with my technical group about that one and look at some case studies and see what we've done on air, and see what can help there.
I think Lee's trying to get you to give away all the trade secrets. So Oscar from Columbia is saying, have you ever used EM telemetries with RSS tools?
Oh yeah, absolutely. Yep, they've been. Yeah, there's no issue running EM with RSS.
The questions are definitely pouring in now. Let's see. Oliver says, do you guys use any EM signal boosters?
We don't typically, no. I mean, that's an option. We do. There are some technologies now that will allow you to put antennas in offset wells that have already been drilled that obviously are not producing, and that definitely helps. I guess kind of something I touched on in one of the previous questions. But no, signal boosters are usually not part of the system that I'm familiar with.
No, what is the best way to improve EM signal when drilling in brine?
Oh, that's a good one. Yeah, I mean, I guess with that, it's gonna be a very low resistance. So you're gonna have a very high current, and I guess the way you would do that is you're gonna have one option is to add an inline resistor to give you some residual resistance there, so you don't damage your components. Or you could design your transmitter boards to handle a little more current, a little more heat. But yeah, that's going to help. I mean, the signals, it's going to be dictated by the resistivity profile.
So follow up, kind of right along that same line of questioning, Paul Pastusik, who's an amazing person. What is the effect of salt or other high conductive layers on signal detection? So our other one was high salt in the drilling fluid. This one's high salt as far as the formation layers.
Yeah, so salt or highly conductive layers, stratigraphic layers, will definitely kill the signal. It has a lot more of effect than the drilling fluid itself, because once you usually these at least in the Permian or on U.S. land, when these salt formations are a little bit higher up, so your signal's somewhat attenuated already, and then once you hit these conductive layers, it kills the signal. That's one of the struggles, and that's one of the reasons that the antennas are being really looked at closely for the Delaware Basin, because there are some salt formations there that prevent good signal detection at deeper depth, TVDs. So
this was kind of a broad question. It's like, what is the battery power needed for run EM MWD?
The battery, the power, typically we'll run anywhere from 1 to 40 watts.
And then Salim had the same question that's kind of similar to Paul's, but this one gives very specific. What's the influence of a thick salt layer circa around 3,000 feet on the implementation of EM? So it goes right along with, I think, with what you were saying just now. I don't want to skip over
with Paul's question, yeah. But yeah, it would, a 3,000 foot, that would kill the signal. It'd be really hard if there was any moisture in it at all, and it was very conductive. It would be very hard to get a signal past that. Now, there are options if you do have offset wells in the area. There are companies that can, I know there's some that we work with, and I'm sure all the other EM providers out there work with, that can lower antennas into these wells. And if you get an antenna below that formation, then you should have no problem whatsoever. You just have to have your second, your second antenna or your second grounding rod below that salt layer.
So generally speaking, farther lateral distance between stakes, the better. Am I right?
Yep, that is correct. That is correct, because you're measuring a voltage difference. So you're wanting as much to maximize the amount of resistivity between the two to give you more of a voltage contrast. So yeah, you can run it further. That's better.
So this is what Mohammed says: do magnetic anomalies have an impact on EM telemetry?
Magnetic anomalies.
So are we talking about formation magnetic anomalies, solar flares,
yeah,
or BHA components?
Disturbances in the Earth's magnetic, yeah. That's I don't think so.
Sorry, go ahead.
No, just to address the last question. Not that I'm aware of. At least no phenomena that I'm aware of on the magnetic side really will interfere bad enough to really cause serious issues.
So Lee said, haha, I have my secrets trying to gain more. So his question earlier about how to do something. The EM can be used to be correctly identify the actual shoe depth. Signal is shorted inside casing. When the gap sub exists, casing, voila.
Nope, that's absolutely correct. Yep, that is definitely one application for it. And yeah, it's another thing. I mean, I guess it goes without saying, but you can utilize MWD or EM MWD if you're inside casing.
All right, sorry, I'm trying to get through the. Says what type of coil is used as a transmitter? He's coming in with a lot of interesting questions.
Yeah, it's not a coil at all. It's a dipole. I guess there may be a core in the transmitter itself, but that I'm not sure exactly, like, in terms of what type. I don't know what specifically.
I think somebody here, I think Bogdan, I think he actually works at Cathedral, says no coil is present in the TXR design. So that's from.
Yeah.
Let's see if I can see.
That's kind of what I thought. I think there might be some sort of. That's not what produces the signal.
Vice President in Research and Development at Cathedral Energy Services. So yeah, I think we'll take that as the answer. Here's a great one from Patty. Can you use a repeater tool to extend the depths to which you can continue to drill in two-phase drilling fluids?
I don't know. I'm sure it's been tried, and maybe our technical group has had some experience with that. But definitely sounds from a conceptual standpoint, that it could be used.
Here's another one from Paul. Says, can you model this effect and predict if EM will be effective?
Oh, yep, absolutely. Our technical team does that. In fact, when we're looking to go into a new area, they'll definitely want to get as much information as they can about the resistivity profiles of the formations and the depths and all that kind of stuff. And yeah, we can definitely model it and get a really good idea about what our signal is going to look like. What power is going to be required to produce those signals. And yeah, yeah, we can definitely model it.
So Brian says, can you downlink to RSS via EM during a connection?
That I think that would depend on the RSS technology that you're using. But you can downlink to the MWD tool, and if there's a direct, and if the MWD tool can communicate to the RSS, I don't see any reason that wouldn't be possible. I'm not aware of any instances where it's being done, but yeah, conceptually it should be able to, as long as there's, again, a connection between the MWD and the RSS, and they can communicate back and forth.
So here we are. I ask the questions. Are your EM tools telemetry also employs BPSK, QPSK, or et cetera, other modulation schemes?
Yeah, our tools do. Yeah, they use the phase shift. Oh, okay, there. Back. All right. So yeah, they do use phase shift keying. What we use is a binary, and I'm sure you could use quadrature as well. Probably you kind of be limited on the applications of that, just because obviously if you're sending it if you've got a phase shift per wavelength or per cycle, it's gonna require a lot less noise to be coherent. But yeah, we use BPSK as far as I understand.
So this one kind of goes back to the antenna, but I want to be able to put this question up there because obviously a lot of these are kind of similar questions, or we're kind of covered in the presentation a little bit, but I still want to be able to put these out there so that we're all up to speed here. Can the first horizontal well on a pad be used to pick up the EM signal from new wells below the conductive formation?
Yes, it can. And in fact, kind of some of the antenna stuff I was talking about earlier, where you lower an antenna down into the wellbore of an offset well. Yep.
What about just hooking up an antenna to the wellhead or casing head on an adjacent?
The wellhead there? Yeah, I mean, on principle, yeah. Yes, yeah. That should be, that's possible.
All right. I think we got all the questions there. All right. Well, here, I have to put this up here at least. Thanks. Very good, Paul. So we made Paul happy. All right. Oh, here we do. We have one more question because this is actually an interesting question that I didn't even think of asking this. What is the success rate in hammer drilling? Have you guys done any applications of that? I know it's done a lot more so on the mining side of the drilling industry, or maybe even water drilling, but
yeah, for a hammer drilling, I mean, yeah, it's possible. It's really hard on the tools from a shock and vibration standpoint, obviously, but it can be done. As far as the numbers on the success rate, I could get with the technical team and look into what we've done, and provide some info on that. But I don't know what the success rate is offhand.
All right, curious how the recent developments on the gap sub still using fiberglass materials? ?
Yeah. Currently, as far as I know, at least with our technology, yeah, fiberglass it's a fiberglass type material.
All right, and I'll take the last questions for myself. So, first of all, thanks so much for being on the show, and we need to put the little branding thing back up there. I forgot to do this earlier. This is the Vidor Locksmith Show, brought to you by Gibson Reports. Yeah. What do you see as the future of drilling technology with the mindset of EM tools? Where do you see those tools going, 5 to 10, 15 years down the road? Joel, can you hear me?
Connection issues there. Yeah, I can hear you now. I didn't catch the last part of that question, but I think I know what you're getting at. What I think it's going to look like, the EM technology evolution is going to look like several years down the road. Well, yeah, I mean, basically, we're going to find a wider range of applications for it. One of the limiting factors here is the depth. Unless you have a an ideal resistivity profile, you're going to have issues in modulating at, really deep depths. And as the antenna technology that I discussed, as that gets more, we collect more data on that and kind of figure out the best ways to implement that technology. That's definitely gonna take us a long way in some of the basins, like the Delaware Basin and the Permian that I mentioned earlier. I think antennas are going to be a big contributor to having EM technology be one of the primary telemetry, MWD telemetries in the Permian, right, or in the Delaware Basin of the Permian specifically. Midland, there's usually not a whole lot of issues. Secondly, as lithium battery technology, gets better, and that's something that's getting better pretty quickly. We'll be able to obviously put more energy, put more power downhole, use more power. So when we have a resistive formation, and we need those higher power levels, we'll be able to get to those higher power levels and for long enough to make it a useful run. So that's definitely going to help a lot. So and there's just with anything, that's kind of mainly where I see it going. And also one thing I did not talk about, but that's really important is dual telemetry as well. There are tools out there now, and I think pretty much everyone that has an EM offering also has a dual telemetry where you have both mud pulse and EM in the same downhole tool, and you can demodulate both simultaneously on surface. So I think that's going to be a bigger thing, and that's going to go a long way in helping us kind of find those areas where EM may or may not be useful. In fact, that's one of the things I recommend if I'm talking to a new potential client that's kind of, we've done the modeling, they're just not quite sure because it's a brand new area. We've never, or anyone's ever run EM in. Dual telemetry is really a great way to go into it. Go in there and you see where you lose your demodulation on the EM side. You still got mud pulse there, so you don't have to pull out of the hole or anything, but kind of gives you some data points to look at.
So one last question for you. What do you see as far as the future of the interaction between EM and drilling automation and being able to get more information from downhole linked into the surface systems?
I'm sorry, that audio was out on that one.
What's the future
of? No. Let's try one more time.
So no, screw it. Guys, thanks you guys so much for watching. We do appreciate it. Next week on the show, we're going to have the guys from Rhyme, BJ Weber and Manoj Gopalan, two friends of mine that I am very, very excited to be able to have come on the show. I thank everybody so much for watching. We had a very, very consistent audience. I mean, we held numbers the whole way through. This is a very insightful and learning experience. And I hope that this is one of the things that lots of people are able to go back and continue watching for many years to come. For myself, I've never run EM tools. I have managed people running EM tools, but I've never been out on location, rigged them up, and put them in the BHA and run them down hole. Just like Scott Kerstetter says, thanks. This was a good intro to EM for me. And Armin says, great first show. Yeah, so this is a lot of great first show of the year, great first show about EM specifically. And I'm going to be picking out more topics kind of like this. So you guys let me know if there's a specific topic where you guys want to learn something about. I will do my best to find the best expert that I can, have them come in and be able to give a presentation so we can all learn and grow and start adding a couple of new things to our resume, hopefully, and say that, you watch this on this Vidor Locksmith episode. If somebody does actually put anything on their resume about the Vidor Locksmith show or Gibson Reports, please let me know. I will be absolutely ecstatic. It would make my year, make my day, or whatever. So, Joel, thank you so much for being here, and everybody over at Cathedral Energy Services for helping you out and being actually amazing clients too as well. So, all right, guys, if y'all have anything else, please reach out to me. Let me know. Have you guys a wonderful and amazing weekend. We'll be back here next week. And as always, almost forgot. I have to give a shout out to this guy, Bryson Varner. does some amazing content on LinkedIn. If you guys haven't seen it, get in touch with him. Armin says, through tubing plug drilling. Sounds good to me. Oh, hey, check it out. Thanks for the show. Looking forward to the next one. My cousin and business partner, thanks so much for watching. Oh, gosh, I got nervous all of a sudden. All right, guys, I got to find the button here. Where's it at? Because I was going to do the countdown. There we go. Close for life. All right, guys, as always, know your industry.